So, welcome to the outdoor lab area of URAC Research. And I present you the facade system interaction lab, where we can test one-to-one scale facade. This is one of our latest prototype. We are at the moment characterizing the thermal and optical performance of the facade in, of course, a real external environmental condition. At the moment, we are measuring on the external side the surface temperature, in this case of the PV panel, but also of the glazing. And as you can see, we shade with aluminum tape the sensor in order to reduce the effect of the direct radiation on the sensor. We're also measuring the in-plane irradiance with a pyranometer, which is installed on the frame, which is very useful then when we have to calculate also the indicators as we discussed in the lecture.
So this is like a real building?
Exactly, with the difference that we can easily change the facade prototype whenever we want. Thanks to these clamps, we can just use this and change very fast the facade prototype, which is installed in this movable frame. Inside there is a fixed frame. We just install the facade inside, and then with the clamps we block the facade, very similar to what we did in the G-value measurement with the sample there.
And what about the rotating?
The rotating, so we have a rail which allows the sample, the facade to, or the lab actually, to rotate according to a specific direction. So if we want to test
Different
orientation, these features comes very, very useful.
Can we go inside?
Yes, of course. So this is the room looking from the inside. So it's, I would say, very close to an office space with a dimension of 4 meter width and 8 meter depth. Of course, there is a twin cell close to this. So also when we have to do comparable tests, it's very useful to have two similar spaces. And yeah, so we can go closer to the facade so we can see how we do the measurement. So similar to what we do in the G-value measurement, also here we have to measure the heat flux that cross the transparent element of the facade. How we do it? With this heat flux sensor meter, which are very, very small, as you can see, because we need to have it very small to reduce the effect of the solar radiation hitting the sensor. Yes. And to reduce this, also we use this very peculiar shading shape, which we change and modify according to the season. So every time we change the season or the orientation of the building, this shading change accordingly. So it's a kind of optimized in order to have the less shading possible for that period of the measurement. Together with the heat flux, we measure also the surface temperature, and with the pyranometer, we measure the direct solar transmission. So we have direct solar transmission, secondary heat flux. On the external side, we have the incident radiation. And with this parameter, we can calculate exactly the dynamic behavior of the facade. So from one side, we characterize directly the heat flux, but also we can give KPI or indicator to the designer for having, let's say, a more understandable
characterization. I have a question. When you mean, so you want to shield the heat flux meter or the surface temperature sensor, because if the solar radiation when the solar radiation is incident on the sensor will absorb some energy. That's the problem.
Exactly.
Okay.
It absorbs energy from one side, so its temperature rise.
And not because of the facade.
Not because of the surface temperature of the glazing, but because of itself.
It's mass, yeah.
Is mass, and this change also the temperature of the surface where it is attached. So it's
Right.
really important. We are measuring something that is not correct if the sun hits the sensor. So it's very important to shade the sensor. So that's why it's so complex to do measurement on transparent facade. Because on the opaque, it's very easier. You see, you attach, so the setup is the same. So we have heat flux, we have surface temperature. On the external side, we have temperature. So we can characterize the conductance of the opaque part, so the transmission, thermal transmission. But here is opaque, so we don't have any issue with
Or
this
shielding.
transmission. On this side, the transparent, we have to be very careful with the shielding.
Very nice to see how the measurement from the lab can be transferred and realized in a realistic setup, no? When outdoor conditions are not controllable, then yeah.
Exactly. That's the challenge, moving from the lab characterization where everything is controlled. But when you go in the real building, but also here, which is a kind of in-between situation between lab and buildings, it's very challenging to do effective measurement and so give real numbers of real characterization of what is the thermal and optical behavior of the facade. So yeah, I would say it's very interesting, very challenging, but super useful.
Yes. Thank you so much.
And this grid has nothing to do with the glass. This is for comfort.
Yeah, right. This is for the internal temperature measurement close to the facade.
So this is the air temperature.
Air temperature and humidity. So same, we have to shield because also for the internal temperature, as soon as the sun hits the sensor, then it changes the measurement always.
But this is for other type of tests, not.
This is for, yeah, I mean, we use this for, is a kind of a matrix, so we can place sensors all around. And usually it's for the measurement, yeah, of temperature in different points, right, of the different heights and different points distance from the facade. So at the moment we are trying also to characterize the temperature in front of the glazing and in front of the opaque part, also to have a kind of average behavior close to the facade.
Thank you.